Hello! Today I'm going to show you how to find the nth term of an arithmetic sequence. So first off, what is an arithmetic sequence? It's a sequence where we add the same number every time to get to the next term. So an example could be 3, 8, 13, 18, 23, etc, etc. And we can see that the difference, like to go from this term to this term, is 5, and it's 5 every time. So that's what kind of defines an arithmetic sequence, is the fact that this difference is the same every time. Doesn't change ever. Could be negative, that's completely fine, but this example is positive. So what do we mean by nth term? Nth term is a formula that we use to take in the position, if we think this is position 1, this is 2, 3, 4, 5, and we take in the position and we get out the value for each term. So we'd take in 2, for example, and we'd get out 8 as an answer. We'd take in 4, we'd get 18. So how do we do this? The first step is it's kind of to start with what the general form is. So the general form of it, we think about xn. This is what we call the nth term. So it's x is the sequence, n is the position, so it's the nth term in the sequence x. And it's always going to be of this form, where we have d multiplied by n plus c. D is the common difference, which is the 5 in the example above, like the 5 across here. It's called common because it's the same, difference because it's from a subtraction. So the 8 take the 3 would give the 5. And the c, it doesn't really have a name, but it's just a general constant that we need. So here c and d are constants. And the way we find c is if we think, well, let's plug in the value for 1, so like the first term. So what we'd end up with is x1 is equal to, well, n is our variable, so when n is 1, we're going to have just d there, plus c. So we can rearrange this and say that c is equal to x1 minus d. So the first term minus the common difference. So let's use this example above and we'll try and find the nth term for this sequence. So we already know that the common difference is 5, so d is equal to 5. The next thing then is to find the value of c. And what we can see is c is equal to the first term, which was 3, minus common difference of 5. So that gives us minus 2. And now we can plug in the values for 5 and minus 2 into our nth term formula. And what we're left with is xn, the nth term, is equal to 5n minus 2. We'll have a look at another example, just to kind of cement the ideas. So if we had a new sequence, that was 6, 3, 0. Sorry, this should be, yeah, and then minus 3, minus 6. The common difference then, we're going down by 3 every time. So we've got minus 3s all the way along. So d is equal to minus 3. We know that c is equal to the first term minus this common difference. So it's going to be 6 minus negative 3. And these two negative signs become a positive, so we end up with 9 on the other side. So the nth term formula then is going to be minus 3n plus 9. Sometimes this can be rearranged and written like 9 minus 3n. Exactly the same answer. Beautiful.